Hello, we'll look at rationalising the denominator in this session, okay? So what does that mean? Well, if we break it up, rationalising the denominator, well, denominator is about looking at the bottom part of the fraction here, okay? So 3 over root 2. Root 2 is the denominator. Rationalising means make it rational. Now, as you know, root 2 is not a rational number, okay? So what we need to do in this question is to make this fraction the same but with a rational denominator. That's what rationalising the denominator is. Now, why would you want to do that? Let me just give you an example before we do that. Okay, so let me just give you another fraction, 5 over 1.5. Okay. See, it's all about writing a number in its simplest possible form. Okay. Now, this here is a number, but it's not in its simplest form. Why is it not in its simplest form? Because we don't like to write a decimal value within either part of the numerator or denominator, okay? So what we want to do is rewrite this so that we've got an integer on the top and an integer on the bottom, and then it's in its simplest form. And how are we going to write that with an integer on the top and the bottom? Well, the simplest thing to do is to multiply the top and the bottom by 2. So on the top we're going to get 10, and on the bottom we're going to get 3. Now 10/3, you can see, is a fraction in its simplest form. In A-level maths, it's best to write it as a top-heavy fraction. Of course, you can convert it as 3 1/3. That's called a mixed number, but it's best to leave it as 10/3. This is kind of the same sort of thing, but we're not going to end up with integers at the top or the bottom. Okay, we're still going to end up with a surd. Okay, but that surd will be on the top rather than the bottom. Okay, so how are we going to rewrite this? Well, similar sort of approach. We need to multiply the top and bottom of this fraction by something. So basically the same number there and the same number there, such that the denominator is going to be rational. Okay, and the simplest thing to do is to multiply top and bottom by root 2. Now I've chosen root 2 because you should be aware that root 2 times root 2 is just 2. So if we go ahead and do that, on the top we'll end up with 3 root 2, and on the bottom we'll just end up with 2. And that's it. Now, it might look more complicated sometimes to you, but this is actually what we call a simplified fraction because the surd is on the numerator rather than the denominator. We have rationalised the denominator. Now, you can easily check these in your calculator these days, okay, because your calculator's got surd functions in them. So if you type in 3 divided by root 2, or write it as a fraction, 3 over root 2, then press equals, then your calculator will give it to you like that. And that's what your calculator often does. It gives you your answers when there's a surd involved in its simplest form with the surd on the top. Okay, so that's what rationalising these denominators is all about. Let's do some more examples. I'll just keep that one there maybe. So the next example I'll give you is going to be 5 over root 7. Maybe just have a think about it before I follow it through. What you've immediately got to think about is what you're going to multiply the top and bottom by in order to get the denominator as a rational value. Okay. Inevitably, they usually end up as being integers. Okay, we're going to multiply top and bottom by root 7. Okay, because if I just do the bottom first, you're going to end up with 7 on the denominator. Obviously, I hope it's obvious at this stage that root 7 times root 7 is 7, and then on the top you just got 5 root 7. And that is it. Okay, we have rationalised the denominator with those. Okay, and it works with fractions like these as well. So let's just do 5 plus root 3 all over root 2, okay? And when we want to rewrite that in its simplest form, again, we'll just look at the denominator. We want to make it rational, okay? So we'll find something to multiply top and bottom by, and we're going to times top and bottom by root 2, okay? Root 2 happens to be a surd that's quite common, okay? There are other reasons for that, particularly when you get into trigonometry, but root 2 and root 3 happen to be two of the most common surds, okay? So multiply the top by root 2, we're going to get 5 root 2, and then here you could leave it as root 3 root 2 if you want, but I often write it as root 6, just that it's easier to write root 6 than root 2 root 3. Okay, you can't actually simplify root 6 as a surd, so it's generally best to leave it like that. And on the bottom you've just got 2, okay, and that's it. I'm hoping those simple examples are easy enough for you to understand. Okay. Now, effectively, that is what you might call high-level GCSE simplification of surds. In A-level maths, you need to be able to simplify some more difficult looking fractions. Okay, so something like this. I'll give you a simple one. So 1 over, and I'll divide it as, let's just put 4 plus root 3. Okay, now how do we do that one? Okay, you want to multiply top and bottom again by something such that the denominator is going to be rational. Okay, have a think about it. Pause the video maybe. Did you think about it? Did you get it? If you didn't get it, I'll give you a clue, then you can pause the video. Think about the difference of two squares. Pause the video again. Did you get it? Okay. Difference of two squares. Okay. Well, your answer is going to be you want to multiply by 4 subtract root 3. How does that work? Well, remember what the difference of two squares is. It's this. Okay. X plus y multiplied by x minus y gives you x squared subtract y squared. Now, why is it important? It's because the xy and xy, one positive, one negative, they cancel, don't they? You just left with x squared minus y squared. Well, what's happening with this? Okay. Well, if we do the same sort of calculation, let's put it in brackets, 4 plus root 3, 4 minus root 3. Okay, we're getting up with 4 times 4, which is 16. I'm not going to write it down, but I hope it's obvious that the 4 times root 3 and the negative 4 times root 3, they're going to cancel. Okay, and then root 3 times root 3 is just 3. You're going to end up with negative 3, okay, which is just, of course, 13. All right, so you can see how that's working. Okay, using the difference of two squares approach, the surd terms end up cancelling, and you're just left with the integer times the integer, and then root 3 times root 3 also gives you an integer, you see. Okay, and that approach will always work. Okay, that approach will always work. So I'm in a position now, let's just finish the working off there. I'm in a position now to be able to write down the answer. So 1 times that is obviously just 1, 4 minus root 3, and the denominator, I've done the working there, okay, so you can see it's just going to be 13, okay, and that is it, okay. If you want, you don't have to, if you want, you can write your answer like this, 4 over 13, subtract root 3 over 13, okay. What I've done is I've just rewritten it, so you've got what we might call the rational component of that answer is 4/13, that's a rational number, okay, and then the irrational component, that's the irrational value, root 3 over 13. Okay. Let's do another one. I'll keep that example there maybe. Let's just try something like this. So 7 over 4 minus root 5. Okay. Maybe just pause the video and do the work in yourself and see if you can get to the answer. Okay. Right. So what are you going to multiply top and bottom by? Think of difference of two squares again. This could be 4 plus root 5. Okay. Now, once you've got the idea, once you've got the method, these are generally pretty easy, okay? Because all you've got to do is just do the same as that, aren't you? 4 minus root 3, just change that to a plus. There, okay? With this one, the same as that, just change that to a minus. So basically, if I give you a denominator like this, let's just make it that, okay? What you're going to multiply that by? You're going to multiply it by 7 minus root 13, okay? So they're generally pretty easy, okay? The harder bit sometimes is actually doing the multiplication itself. Okay. Now, so far I've been writing my working across the page. Okay, but when you've got more steps involved, it's best to go down the page. Okay. I say page, of course. I'm thinking about you taking notes in your exercise book. Okay. So I'm going to put my next bit of work in here because remember previously with that one I did the working of that times that separately. Okay. You can do the same if you wish. Okay. But what I'm going to do is I'm going to write down the next stage here. So 7 times all of that, so that's 28 plus 7 root 5 over. Some of you can do this in your heads. If you can, great. Okay. If you need a bit of time doing the working, okay, it's fine. So 4 times 4 is 16. If you want, you can write it down, but we should know that the 4 root 5 times the 4 times negative root 5, they're going to cancel. Okay. Some people like to write that in, plus 4 root 5 minus 4 root 5, but they're going to cancel. Okay, and then minus root 5 times root 5, so minus 5. So that's sometimes the additional bit of working that some people like to put in. Let's just rewrite that. Okay, so it's 28 plus 7 root 5 over 16 subtract 5, 11. And that's your answer. Okay, if you want, you can write your answer as 28 over 11 plus 7 root 5 over 11. Okay. Right, next I'll give you just one more example. and hopefully that's enough for you. Okay. If I've rubbed it off too quickly, I'm sorry, but this is the advantage of video, so you just rewind it and put it again, and then freeze frame it. Okay. If you want to freeze frame it and print it off and use that as your notes, yeah, fine, be my guest. Just try and get me out of the picture. Okay, you don't want me all over your notes, dear. Let's just have something like this. So 3 plus root 2 over 1 minus root 3. Okay, so it's obviously a slightly difficult looking fraction to simplify that, isn't it? Okay, because I've got a third on the top and a third on the bottom. Okay, but the objective, as ever, is to this. We'll go back to the title, Rationalising the Denominator. As soon as you see a fraction where the denominator is not rational, then you've got to rewrite it, you've got to simplify it. Okay, so what we've got times the top and bottom by? Well, it's simple. We'll just look at the denominator. 1 root 3, just change that to a plus. So it's going to be 1 plus root 3. I'm going to write the denominator first, just so you can see what we're doing. That's the difference of two squares, you see, that times that. And then the numerator, okay, 1 plus root 3. Let's just take a moment to think about why this is always working, okay, why we can always multiply this fraction by something. Well, if you think about it, if you go back to all the examples I've done, this fraction is just 1, isn't it? 1 plus root 3 over 1 plus root 3. It's just 1. If you times any number by 1, you get the same. It's the multiplicative identity, isn't it? Times a number by 1, no change. Okay, that's why this is always working. Except obviously we're just writing it as 1 plus root 3 over 1 plus root 3, just so that we can do something with the denominator. Okay, so here's where it's a good idea sometimes to show a bit more lines of working. Now, you might not always do this, okay, but I'm going to for this example because it's slightly more difficult. Yeah, let's just do it like this. I'm just going to rewrite the fraction like this. You don't have to. I'm just breaking it up into more manageable steps in case you want to see more lines of working. Okay. What we're doing, of course, is doing that times that and that times that. Okay. So you can see why you need to be good at expanding brackets. Okay. Because we're doing it for this work as well, just with numbers. There's no algebra here. Okay. There's no x terms or anything like that. Okay. So what we're going to get. So let's do the expansion. 3 times 1. Okay. Now, if you want, you can write it out as the traditional FOIL, first, outer, inner, last. So 3 times 1, and then 3 times root 3. Okay. And then the inside, 1 times root 2. And then the last, root 2 times root 3, which I'm going to write as root 6. Okay. Now, notice that doesn't actually simplify, does it? Because root 3, root 2, root 6, completely different thirds. You're not going to actually simplify that on top iron. On the bottom, what we're going to get, 1 minus root 3 times 1 plus root 3, so 1 times 1 is 1. Look, I'm just write it out in full, okay, so you can see again the cancellation. So 1 times 1, root 3 times 1, so that's root 3, and then negative root 3 times 1, negative root 3, so that's the cancellation, you see, root 3, subtract root 3, and then this is going to be negative 3, okay, so what we're going to get, so on the top, 3 plus 3 root 3 plus root 2 plus root 6. Remember, I did say that's not going to simplify. And at the bottom, you've got 1 minus 3, which is negative 2. Okay. Now you might think we'll stop there, okay? But remember, the whole part of this process of what we're doing is we're trying to simplify fractions, okay? Just as we wouldn't want to have a decimal in either the top or the bottom of a fraction, it's always best, if you can, to keep the negative on the top or at the front, okay? It's not ideal to put the negative on the denominator, okay? So what I'm going to do with that is I'm going to just put that negative at the front like that. It's the same, okay? So I'll write as negative and then all of this. The alternative, if you want, is to write it as negative 3, subtract 3 root 3, subtract root 2, subtract root 6, all over 2. But I'm just going to keep it like that, okay? I'm hoping that was helpful for you. Remember, of course, you can just rewind and go back through some examples again if you wish to do so. Okay. Good luck with the exercise, and I hope that was helpful to you.